A conservative force is a force that does zero work on any closed path. What is conservative force? What kind of a force that's conservative? Gravity. Gravity is a conservative force. Let's see if that's true. Let's say we have a box. Here's a box. Doesn't matter how heavy the box. mg has a mass m. And you're going to pick this box off the floor. You're going to walk horizontally this way. You're going to climb up, I don't know, pick a height, 10 meters. Then you're going to walk, let's say we walked 5 meters this way. You're going to walk 15 meters this way. There's the box you're carrying. I should put the box here. We're lifting the box. Then you're going to walk down 10 meters and back this way 10 meters. If I calculate the work done by gravity, if the result is zero, that tells me gravity is a conservative force. When you look at gravity, well, there's the weight down. That's what gravity does. The weight, which is mass times gravity. It is always pointing down. When you start from here, let's say this is the start point. What is the work done to go from this point, we'll call it point A, to point B? So what is the work done to go from A to B? How much work is done by gravity to go from A to B? Zero. Why? It's force times distance times cosine theta. The angle between the force and the distance is 90 degrees. So it's mass times gravity times the 5 meters times cosine of 90 degrees, which is zero. So there's zero work done by gravity when you go from here to there. From B to C, we'll use that as C. What is the work to go from B to C? Notice gravity is down, but which way are you going? Which way are you moving? Up, right? This is rocking up here. This is horizontal, that's up. So horizontally, that's zero. Now this one will be the force, which is mass times gravity, times the distance, which is 10, times cosine, the angle between them, which is what? 180 degrees. So what's the result? Cosine of 180 is minus. That's a minus 10 times mg. I don't care what m and g are. From C to D. To go from C to D, what is the work done by gravity? Zero. Mass times gravity times the distance, which is what, 15 meters? Times what? Cosine 90 degrees. Cosine of 90 is zero, that's zero. From D to E. What is the work done from D to E? You're moving down. So the force is mg, the distance is what? 10, and what's cosine, what angle? 0 degree. You move in the same direction as the force. Remember we talked about negative work, positive work? If you're pushing and you move in the same direction, that's positive work. If you're pushing but you're moving backward, that's a negative work. This one you're pulling back, but you're going backward. That's why that's a negative work. This is going to be positive work. And that's equal to 10 mg. And what is the work done finally to go from E to A, to the starting point? That should be 0y. It's mass times gravity times 10 times cosine 90 degrees. And that gives me a 0. So when you add all these values, what is the sum here? It is 0. How much work is required to go around this path? Completely 0. So if I go to the gym right now and I pick 300 pounds weight, and I bring it here, and I walk on this floor 10 laps, the work done by gravity is 0. Why? Because gravity is pulling down and I'm staying horizontal. Where the work is going to be done is to get that weight from the first floor to which floor are we on? The fourth floor. What is that height? And the path that you take is really not important. So the amount of work is done by gravity to go from the first floor to the fourth floor, if I take the stairs, is the same as if I went to the first floor, walked around the first floor, took the stairs, went to the second floor, walked around the second floor, took the stairs to the third floor, walked around that, all the way to the fourth floor, walked around that. The work done is the same as if I took the stairs straight forward. The work done by gravity is the same. It's mad because notice when you're going horizontally, the work done is 0. So if I walk around the floor 10 laps, the work done by gravity is still 0. Yes?
The work done on CD is the 90 degree.
CD.
Yeah, is the 90 degree
angle
at C or at D?
No, you move in this direction, right?
Yeah.
And this is the way down. See the angle?
So it's at D.
Yep. No, it doesn't matter. The whole time is 90. No, at any point during that path, you're moving from here to there. I'm not talking about this angle here.
Okay.
Anytime you're moving from here to there, you're moving to the left, and you're forced the entire time is which direction?
Yeah.
Down. So right here, the weight is down, but you're moving which way? In that direction. That's 90 degrees. The weight is down here. You move in that direction. That's 90 degrees. The weight is down here. You move in that direction, 90 degrees. The same thing here. You go into the right, and the weight is down, 90 degrees. You go into the right, the weight is down. You go into the right, the weight is down. You go into the right, the weight is down. So that's why in this segment, still also 90 degree angle between them, and that's why cosine of 90 here end up with 0 work done. Here, actually, you're moving this way, and you're forced in that direction. That's a 0 degree. Here, you're moving this way, and the weight is down, you're moving that way. That's the 180 degrees. The entire path there, from B to C, you're doing the same thing. So gravity is a conservative force. So let's take a couple of examples here. Another example similar to this. We'll put some numbers in it. We have a box that's 4.57 kilogram. You're going to start from point A, that's right here, and I'm going to move the box. The box has a mass of 4.7 kilogram, 4.57. There's two ways to get to the point. I want to go to point B, which is right here. One way of doing it, is I can climb up like this. Let me draw pictures of the box along the way. I'll make the box small so you get to see what's going on there. I'm going to climb up like this, travel this way to point B. I can do that. And if I do that, this distance from here to there is 1 meter, and this distance from here to there is 3 meters. That's path number 1. path number 2, I can take the box and go 6 meters in this direction. I can climb up there 2 meters in this direction. I can come back in this direction of 3 meters. Then I can come back down 1 meter. Oh, it's supposed to end at B, not at the letter B, at the dot B. So I have two options. I can do it. Option 1 is this one. Now option 2, I can go this direction. I can travel this way, up this way, left and down. Or I can go up and right. And let's calculate the work done if I go path 1 and if I go path number 2. What is the weight of the box? The weight is what? Mass times gravity. The mass of the box is 4.57. Gravity is what? 9.8. .57 times 9.8, which is what? 44.8 roughly Newton. Let's see the work done if I take path 1, which is go up 1 unit and go to the right 3 units. So I'm going to go up 1 unit and I'm going to go to the right 3 units. That's path number 1 from A to B. When I'm going up there, my weight is pointing which direction? Down. And I'm moving which direction? Up. So what's the angle between these two? 180. So it's going to be the force times distance times cosine theta. Let's see. The force is going to be the weight, which is 44.8. The distance is 1 meter times cosine 180 degrees. I'm going to add to that this one when I'm going from this corner to B. Now from this corner, my weight is pointing which way? My weight is down, and which way I'm going? From here to there, which direction you going?
Right.
To the right. So notice what's the angle between the two vectors? 90. So plus 44.8 times the 3 times cosine 90 degrees. Cosine of 90 is 0, the second part is 0. That's negative 44.8 joules. Part B has the box. I'm going to travel this way, 6 meters. I'm going to go up 2 meters. I'm going to go to the left 3 meters. Then I'm going to come down 1 meter. That's part B. Let's see how much work. So this is a 1 and this is 2. How much work is done if I take this path, path 2? Again, for the first piece here, I'm traveling which way? To the right. And which way my force is? My weight is which direction? Down. So notice the angle between them is what? 90 degrees. So it's going to be the force, which is 44.8, times the distance, which is 6, times cosine the angle, which is 90 degrees. Add to it. And by the way, if you do the math, this number is a 0. For this, the weight is which way? The weight is down. Which way are you moving? Up. What's the angle between them? 180. So 44.8 times the distance, which is 2, times cosine 180. Add to it. This one here. The weight is down, and which way are you moving? You're moving to the left and your weight is down. What's the angle between them? Still 90 degrees. And the last one, I'm moving down, and which way is the weight? Down. So the angle between them is what? 0 degree. So let's see what this number is. These two are going to be 0, because the cosine of 90 is 0. The cosine of 180 is minus 1. The cosine of 0 is 1. I'm going to end up with negative 44.8 joules for a final answer, if you do it. Because this will be negative 2 times that number. This is positive 1 times that number. So it does give you negative 44.8. So since gravity is conservative, the path that you take does not really matter. All that matters where you are when you started and where you end up. Actually, I could take path number 3. If A was under that, well, I can make my own path. Just have it go up 1 unit. If you just went up 1 meter, you're at that level. Doesn't matter. So I could have made another path number 3, which is go all the way there and come back. You'll see it's the same answer. So remember, gravity is conservative force. That's going to be a big thing for us. Well, if gravity is conservative, we have something called